All right, so we're back, and I think this is week 4 now. So basically, my first month, um, I guess already occurred. It's been a month, and this week, it's gonna be a pretty short because I'm pretty sure the only thing that I really did was complete this project, and then I did a little bit of deep learning with some linear algebra refreshers. But um, finals week is next week, and this week I also had an exam right before finals week, so did not have too much time. But after next week, after Wednesday, my last final, I should be free to do as much of this as I want without anything else, right? So, anyways, let's look at specifically what. Oh yeah, this is the housing competition. So this is the housing competition for Kaggle. It's one of the most basic. It's like the infamous ones, or like the most popular ones, are this housing competition and the Titanic one, right? But it's two different ones. Titanic was classification. This one was specifically regression. So what I did, let's walk through. Let's just look at the data really quickly. Um, let's see here. Okay, I guess I can't really look at the data, but basically it gives you a bunch of features on the houses, and you know you take a look at all the features. You look at maybe which ones you pick as your main ones, or just the features, and then you make a prediction on the house price when you're given all these other information. Right, so obviously import the file. Then I imported some data visualization, right, for exploratory data analysis. I read the files. um, So the first thing I did was I first took a look at, you know, all I used this the info because I wanted to see, where the especially the data is missing. I guess realistically I could have done is null, right? But this also tells you, where the non-null objects are. And I thought I just like info more personally. Um, so yeah, I took a look at this and I realized, okay, Alley clearly does not have a lot of data. Um, what is this? Fireplaces is losing a lot of data. Pool, QC, fence, and miscellaneous features. All of these are very missing, like quite a bit of data, right? Like a very good majority that I was comfortable enough to just remove them. So I dropped these for both the test and train data. Actually, I didn't know about the pd.concat, the concatenation feature, until like near the end. That's why I never used it. The pd.concat is much more useful, and I'll actually explain that I actually ran into an issue later why pd.concat is more important than um, it's actually an important step. So then I just looked at unique classes, and I kind of this wasn't the best step in the world, but I did it already, so I didn't go back and fix it. But I kind of looked at the MS zoning, and I wanted to see how correlated it was to sale price, and made up some violin plots. I think I used a box plot too, but violin plots are sometimes easier to read. So I read this and I was like, okay, so they have like, each of these categories have their own price range, but it's not, it also depends on, how much data there is for this. So for example, um, like if I remember correctly, C for this specific section, it only had like very few houses that actually had this specific MS zoning category, and I think FV and like these ones had a lot, so it was skewed, right? So that's something to account for. Um, but then I kind of looked into the MS subclass and just went on, and basically what I did was, because this is not a categorical. If it's categorical, I know that I'm not going to touch it. I'm just gonna wait and make a dummy variable near the end. And because this is a continuous one, I just kind of split it using a linspace, and I split it, and I just made this. This is not exactly the best thing to do, but I decided to do it because when I started this in my head, I'm like, okay, you know what? I'm just gonna break it down, split it down the center, you know. And of course, I verified that 190 was also the maximum for the test set, not just the training set. So I did this for both the test and training data. And then I took a look at lot frontage and lot area. I actually did something really dumb initially. I thought that I could use a ratio or something with a lot, like right here, you can see a lot ratio. But what happened with the lot ratio is it's not very useful. Also, I didn't even fill in all the null data yet. So it was just this was just not a good step. I did receive or I did use a lot of information. I had another one where uh oops, I looked into one specific other data set or one other tutorial that was doing this, and I did, I guess, copy a little bit from that because I needed to make certain graphs and I didn't know how to do it, so I had to look that up to see what he did because that person made it very clear visually to what I was looking at later. But a little more on that later. So I then, you know, I dropped the street because the street, I think I looked at some of the correlation. I deleted some of the code because this was getting really, really long. I think the street specifically didn't have much correlation with it, so I was like, okay, I'll drop it. And actually, let me just skip a little further ahead because what I should have done, the first step, one of the first few steps I should have done is, first of all, fill in all the null data. That's the first thing you should do. And second of all, I needed to, right here, this is just the best thing ever. This heat map is super good. Yes, I did copy this. I think I changed the figure size a little bit, but other than that, this was copied because I really like how this information was presented on this. It's super clear to see exactly what I was looking at. And if your text is like overlapping, I think this is the FMT. This is like formatting. You can, if you do this specifically this code, then it kind of looks like this. But anyways, yeah. So I looked at what was strong correlations, what didn't have correlation, right? So obviously ID really doesn't have any correlation with the sale price. ID is just, your 1, 2, 3, 4, 5, and so on, just assigned to it. But you can see that overall quality and these stuff like um, garage living area, or I think this is garage living area, or ground living area. I'm not really sure. I don't really remember. Total basement square footage, first floor square footage, and all that. These have really strong correlations. So I really should have done first was look at this and look at the ones that really have zero impact. Um, and maybe I could make this 2 decimals, but when I see something that has almost literally zero correlation, I'm comfortable enough to drop it because I mean, like it this graph presents it doesn't really have any correlation. There are exceptions though, because there just could be other cases where there's always exceptions, right? Uh, but for the purpose of this, I would just drop it. So yeah, this is what I should have done first. So then, moving on, what I did was I looked at what is this? Lot frontage and all that stuff. Looked at the mode. Yeah, this was just filling in missing data. If it has like very little that I'm missing, like maybe less than 1%, maybe like 0.1% of the data is missing, I'm comfortable enough to just fill in with the mode. Um, but if it's missing a little more, then maybe you want to use a mean or the median, depending on how skewed the data was. So yeah, these were the missing columns, and then I looked at these small ones, and then I dropped whatever it is. And then what I did was, uh, so this was still dropping, uh, again, filling in missing data. These had like very little. Yeah, okay. So this is what I did. This is now where the combination of data comes in. And this was, to create this plot, I didn't even know how to do this. I definitely looked this up. I'm not gonna lie. Uh, because these were overlapping when they were horizontal text, so I needed to flip it vertically. And I thought that 90. I first initially did 90, but I had to keep like tilting my head to read it, so I actually changed it to 60. And these were neighborhoods. This is actually inspiration from the guide that I was reading. The guide, he uh, basically grouped similar neighborhoods together, so then that when I made a dummy variable, I wouldn't make like there's like 20 something here. I wouldn't have to make 20 separate dummy variables just for this. So yeah, I actually grouped some of them together, and I did this by eye, kind of just looking at this. Obviously, it's not the greatest. There's definitely more mathematical intuition and mathematical precision you can do with this. But for the purpose of this, I just grouped it with eye, and I made it 8 different ones. And then I assigned a dictionary to it, giving it, respective numbers from 0 to 1 to 7, from 0 to 7. And then I took a look. Oh yeah, yeah. Then I just mapped it so that you know this one would have that respective number. Yeah, moving on. I was looking at the open porch surface area and the sale price and trying to see if there was a linear relationship with it, but I couldn't really support that there was linear relationship. So I think right here I'm just checking on, yeah, I'm just checking how many more columns I'm working with, and here is where I'm categorizing. So previously, what I was doing was I was working on one column and I'm splitting them into different groups inside that specific column, right? Now I'm taking multiple columns and I'm actually grouping them together into a new column so then I can remove these columns and just use that new column, so I'm only working with one rather than how many does this have, like one, two, three, four, like I don't know, 10 other different columns, so I could just like straight up get rid of these columns. So yeah, that's when I was starting to look at this and it's like, okay, so we're looking at square footage here, and what I did with square footage was total living square footage was just the basement's total basement square footage plus the first floor square footage plus the second floor square footage. And how the square footage worked was it's kind of weird because I think the low quality um square footage was, there was some relationship that you had to subtract something, add something. That's why it was added this specific way. But regardless, I was just combining this and I was looking at outside square footage and total living square footage. This was definitely inspired by that guide again. Um, I guess to me the problem I ran into was there was just a lot of columns to look at. So I was starting to get confused on which data I should combine like with one another. So yeah, then I just dropped all these. I combined them, I dropped them, and then quality, we just looked at quality. Now we're looking at everything that has the word qual in it. And then we can make a total quality. Uh, let's see here. This is right. So some of the qualities were actually um, categorical. They weren't numerical. So some of them, like total quality, was on a scale of 1 to 10. I think it's like 0 is very poor, and then 10 was like very excellent. But it was actually ranked differently for some of the other qualities because they had, it could be an A, which means that like they didn't have uh like basement quality, for example. If it says an A, it means that they didn't have a basement, so it's just 0. And then a bunch of other stuff. Basically, they assigned a variable to it rather than an actual numerical value. So what I did, again, this is inspired, was I assigned a value to each of these ones from 0 to 5. And then this is just me mapping to these specific values. Then you can just add them together, and then we get these. So the rest is pretty much the same thing. Bathroom, combining bathrooms, and then these are me dropping these because I'm seeing, okay, I don't see a lot of correlation, so I might as well drop them. And then I finally took a look at the heat map at the very end that I had, and it was looking like I had a lot of good data to work with, like a lot of high correlated data. Oh wait, I needed to look at sale price, a lot of high correlated data, a lot of red, right? Because these are the ones, these 1, 2, 3, 4, 5, 6, 7 columns right here are the combined data. As you can see, they're very, or sorry, 6 right here, are very, they're like have a really strong correlation, except maybe total condition. But it's still pretty strong. So finally, I dropped some more that I felt like wasn't useful, like miss val 0.0, screen port 0.0, and then this is where I actually implement the machine learning. But like I said before in one of the previous videos, a lot of this is just you need to manipulate the data. Like the machine learning algorithms and stuff, sure, the only thing that you may have to worry about and play with is the features, because obviously a lot of the the machine learning algorithms, they have a lot of settings that you can adjust. Like, I don't know, it could be alpha or like, the kernel you use or whatever. So just make sure. So pretty much 90% of playing the game is the data. It's not even the machine learning model. So with regression, I actually didn't know a lot of regression because the stuff that I've been learning has mostly just been classification. So I did decide, what I did was I first ran a linear regression, and for linear regression, um, I don't know if this one was linear regression. Yes, this one was linear regression, right. So for this one, for linear regression, I actually got a score of 19,224, which was not bad. For like, I was actually very surprised that the linear regression was like fairly good. Um, so yeah, but what I had to do was I used this. Uh, actually, let's go back to sklearn cheat sheet. I think it was this one. Yeah, I used this one. So I was like, okay, I'm definitely doing quantity. I'm doing a regression, right? So it's like few features should be important, and I looked lasso and elastic net, and that's exactly what I ended up running in the end. So as you can see from this, it seems like only few of the features are important, right? It's this. These six features are important compared to maybe, let's say, the other few. Um, so I thought okay, maybe if I ran that, and actually, I think lasso was. I actually don't even understand any of the mathematics behind lasso or elastic net. I'm not gonna lie, but from what I saw, it looked like lasso and elastic net did perform, or sorry, lasso performed better than elastic net, and lasso actually outperformed linear regression. Uh, but elastic net performed slightly worse than linear regression. Then I also did, I don't remember. Yeah, I also did SVR, support vector regression. That didn't work well at all, and I don't know why. Maybe it's because my kernel was an RBF, radial basis function, rather than a linear. That could be the problem. But yeah, it was not giving good results. Like my error was very, very high. And also I did play around with standard scaler, standardizing the data and scaling the data, and it gave really mixed results. It either did performed a little bit better or it just made it a lot worse. So near the end, I just stopped messing with it. Um, but yeah, that was basically it for this week. Other than that, I watched some lectures on deep learning, specifically, I guess, neural networks. Oh, yeah, I guess I can continue editing. Neural networks, deep learning. So currently in TensorFlow, just looking around, and I guess I did understand, some concepts, like the theoretical parts, or the intuition with gradient descent, cost functions, back propagation, um, and just stuff like that. So next week, I think I'm definitely gonna get deeper into deep learning and kind of give a little more outlook or provide some like a a video about what it is that I learned and like some of the intuition behind it. Maybe I can break it down. But yeah, so that's it for this week. So I'll see you guys next week.